Hi everyone, welcome back to the Arun Sharma Academy. And in this lesson, I'm looking at an expansion of the concepts of the triangles chapter of geometry from class 10th of mathematics in the NCERT books. Now, there are two kinds of people who will be watching this video. One of you would be those who are coming here to improve your geometry for exams after you have finished your school. You're looking at some competitive exams, etc. So for them, of course, the playlist that you have to watch this in is part of the entire NCERT class 6 to 10th covered playlist. And of course, if you are a school student who's watching this, then you will obviously go to the relevant playlist of your class, and you will just watch that playlist from there. So without any further ado, let me start off with discussion of what the main agenda in this session is. So in this session, I'm basically discussing the basic proportionality theorem. And it's an important theorem, and it's one of the theorems that allows you to measure side lengths based on the proportionality logic that this theorem talks about. So what does this theorem say? What this theorem says is that if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. Now that might seem a little bit confusing for you to understand. So hence, I will try to explain this to you through a actual drawing and a pictorial representation of this. And this picture, in a lot of ways, represents to me what the basic proportionality theorem says. So if you look at this picture, what it's saying is that if I have the line D here, if you look at this this picture, and if you look at the line D here, this line D here, so this line D, if it's parallel to BC, then the point D would split the AB line into two parts, AD and DB. Likewise, the point E splits the AC line into two parts, AE and EC. And what the basic proportionality theorem says, that if DE is indeed parallel to BC, if D is indeed parallel to BC, then the ratio in which D splits the line AB, that is the ratio of AD by DB, would be equal to the ratio in which the point E splits the line AC. So this would be equal to the ratio AE by EC. This is what the basic proportionality theorem says. So this part and this part, the ratio of these two parts would be equal to the ratio of these two parts in case DE is actually parallel to BC. So this is the basic proportionality theorem, and it's used in a lot of situations. Suppose I tell you that this is 2 and that is 3. And then I say that this is actually 5. So what is this length? You can basically apply the same multiplier that you see from 2 to 3, which is a 1.5 multiplier on this side, and multiply this by 1.5 to get this value of 7.5. So it's a very important theorem because it's used in a lot of questions where lengths have to be measured in triangles. And as you go into competitive exams and competitive mathematics, you'll see a lot of such examples of questions. But what I want to go to, the theorem is basically just that. But what I want to go to from here is essentially what I call as interesting but confusing proof and what's wrong with the way geometry is taught. So coming up, I'm going to show you why geometry becomes difficult for a lot of people to understand. This is my experience, and I'm just sharing my experience with you. why I find that geometry becomes very difficult for people to understand. Picked up the proof of this theorem from the NCRT book, and in a lot of ways, this suggests to me everything that's wrong about the way geometry is written about and taught in the context of not being able to connect to a logical mind. So, if you look at this, this is the proof that is given to us. So, we are given a triangle ABC in which a line D is parallel to side BC, intersects the other two sides AB and EC, AC at D and E respectively. We need to prove that AD by DB is equal to AE by EC. That's the basic proportionality theorem. So it's fine till here. Now my objection to the way maths is taught starts from the next point. Let us join B and CD and then draw DM perpendicular to AC and EN perpendicular to AB. We need to prove that AD by DB is equal to A by EC. It's fine till here. But let us join B and CD and then draw DM perpendicular to AC and EN perpendicular to AB. Now, the problem with this writing and this communication is that they are not telling you why you should think that way. And unfortunately, as you understand, when you go into a maths question, when you try to solve, maths is about question solving and reactions. When you try to solve a maths question, you're basically trying to develop your quality of thinking or your ability to think inside a situation. So when you would further go ahead and start solving questions like this or situations like this, you have to develop your mindset or your mind, your thinking mind about these constructions. Why should I do these constructions? So as you will see, this whole proof is completely silent about why we should do this. So if you just read through, you'll realize that this proof is completely silent at why they have connected this. And as you understand, when you read something like this of a textbook or a teacher who does not explain to you right at the start that why is this being done, it obviously becomes a difficult thing to work out. Ki kya karna chahiye? What should I do this, or how should I organize this thinking? So I personally believe that this is perhaps the reason why a lot of people come out with distorted minds when they come out of school, and I've faced this a lot in my own teaching career when I tried to teach people how to take aptitude exams and prepare for aptitude exams, and maths came back in their lives after 3-4 years of not having it. So a lot of people, I could make out that people were basically never taught how to think inside an aptitude inside a mathematics question. And unfortunately, that's actually the only thing you need to teach a student. So I often tell my students that when they come to me with broken beliefs in maths, especially, and 80% people who prepare for quants or mathematics after graduation for any competitive exams have that problem. So I often try to convince them that maybe it was a communication problem, because I see this communication problem in almost every chapter. And one of the endeavors we want to do at the Arun Sharma Academy is to actually change this and help you understand mathematics a little bit better by showing you exactly what you need to see. So how would I want to explain this concept to you? So just let's go back to the blackboard and try to see what's the process through which when we're trying to prove this. Now, whenever you try to prove something, prove a formula or a theorem, the first thing you need to understand is that you have to use things that you already know to show things that you want to show. So in this case, the objective of the proof is to show that AD by BD will be equal to AE by EC. Of course, instinctively it does look like that, but that is not how mathematics proofs go. So when you want to think about AD by BD and AE by EC, when you want to think about these two values and these two side ratios or length ratios, one of the thoughts that comes to mind is that if you actually, or the way you can think about this is that if you actually look at this line AB, this line segment AB, so what you can see in this line segment AB is that it is the source of two triangles, the triangle with ADE and the triangle BDE. And obviously the base of the triangle ADE is AD, and the base of the triangle BDE is BD. Right? But what is important to understand here is that they have the same height. So if I construct this point, and I'm going to use exactly the same points that they have talked about with us in the NCRT textbooks, so I'm using n here. So if I construct this height En, so what happens is that I can actually write the ratio of the area of AD to the area of BD as, I can write the ratio of the area of AD to the area of BD as half base into height. And since the height is En for both these triangles, I mean, if you remember your pictures, and that's one of the things I keep telling you, that geometry is to be organized in your mind in the form of pictures. This is the height of the triangle. But in this picture, pardon my drawing, in this picture, this is the height of the triangle, an obtuse angle triangle on its obtuse side. If you take a base on its obtuse angle, then its height lies outside it, and that's what exactly has to be done for the BDE triangle. So this En is actually the height for both these triangles. So half base into height, if you use half AD into En upon half BD into En, that's the ratio of the areas of ADE and BDE. So what happens is that the En will cancel as well as the half will cancel. So what you have done with this step is you have converted the ratio AD by BD into the ratio of the areas ADE by BDE. So this is what you have achieved by doing this. And if you look at the proof, look back at the proof that is shown in the NCRT books, you will see that they don't talk about any of these intermediate thoughts, which is actually what you need to train somebody to think about. Because when you go into problem solving situations in maths, you have to think, I mean, you have to learn how to think inside the situation. And most of our maths books and maths teaching is actually completely removed from what you need to think inside the situation. So we have converted the left hand side into the ratio of two areas here. So we have reached a point where we have been able to convert the left hand side here into the ratio of two areas. If I try to do the same thing for the right hand side, and I look on this line, AE and EC as the base, then I can see that the triangle AED, that you see here, and the triangle CDE that I can construct by connecting CD, which is why I should connect CD. Both these triangles again have different bases. The CD triangle has CE as the base, and the AD triangle has AE as the base. But again, their heights are going to be same because the vertex, the top vertex is D. So if I draw the perpendicular from D to, let's use M, which is what NCRT used here. If I draw the perpendicular from D to M, then I'll get another ratio or a conversion of the ratio of AE by EC into area of two triangles. So the area triangle, I mean, I'll just write it here. Area triangle ADE divided by area triangle CD will basically be half into AE into DM divided by half into EC into DM. And again, you can see that the half will cancel out and the DM will cancel out. And your theorem now on the right hand side is AE by AC, EC. This right hand side of your to prove logic has converted into two triangles. So to prove what we need to prove on top, we need to prove now that area triangle ADE divided by BDE is equal to area triangle ADE divided by CDE. I'm using A here. Normally the logic is to use AR, but I guess that much you can understand. So obviously that means if I want to prove this, if I can prove this, I will have proved that. So the question has diverted itself. The question has moved away from where we were to the proving of this thing. Now obviously it's very obvious that the numerators both these are same. Both of them are this area triangle ADE only. So that's pretty okay. But if you look at the denominator BDE and CDE, we need to then prove that BDE is equal to CDE. So the thinking takes you to this point, and your movement or your thought process moves to this trigger point where you have to think about why AD, BDE and CDE are equal. Because if you can do that, that's the last hurdle in this question. If you can do that, you will be ending this proof. So if you think about now why AD and BDE and CDE are equal, let's just focus on what BDE is. So BDE is this triangle. I'm now using the red marker here. BDE is this triangle. Maybe I'll just use a deeper color of red. BD is this triangle, while CD is this triangle. And if you look at both these triangles, they have a common base. The common base is that D. And since D and BC are parallel, the heights of both these triangles will be same. Because whether the vertex is at B or the vertex is at C, the height will remain the same, which means, and this is also a theorem that you study in mensuration, that if two triangles are drawn to the same base and their tops are on the same parallel line to the base, you put their tops or the third vertex on such that the third vertex is on the same parallel line, then the two triangles area wise is same. So I'll be doing a separate group of videos for mensuration from class 6 to 10th, and we'll look at this theorem specifically there. But this is how you prove that BD and CD are equal. And once you prove that, you have actually proved the basic proportionality theorem. Right, so this is the proof of the basic proportionality theorem. Of course, if you're going for aptitude maths, proofs etc. are not so important. But what is definitely important for you is to start thinking about how do you think inside problems, not get led by this kind of thinking which says that don't join these lines. Why should I join these lines? Ultimately, they have to teach you that. Of course, this theorem has its converse also, which is another example of poor explanation of this. Maybe I'll do a separate video for this, but for the time being, You can just understand the converse. If a line divides any two sides of a triangle in the same ratio, then the line must be parallel to the third side. So while they have a proof for this, I will currently skip that, and we'll discuss that proof maybe in a different lesson. Thank you so much for being invested in us, and I will see you again in the next video very shortly. Bye bye.